Today we're going to talk about one of my favorite things, doing heavy stuff while keeping a smooth rendering flow. So let's talk about asynchronous code. Hello there, I'm Attila, I'm a web developer and I like recording videos about making things that would otherwise be difficult look a little bit simpler. And today we're going to talk about doing some heavy lifting without leaving the front end. And to do that, we would use asynchronous code. And there are actually two ways of doing asynchronous code in JavaScript. There's the parallel and there's the concurrent way. By default, JavaScript code executes in a single thread. This means that your promises, set timeouts, set intervals, fetch requests, whatever have you, everything happens in the same thread. The asynchronous nature of this code happens because our engine is efficient, smart, and fast enough to jump between processes in order to keep everything running smoothly and feeling as it's happening at the same time. That's concurrent async code. But since we got workers into our language, we can now have parallel execution as well. As the name suggests, parallel execution means we spawn a whole different thread for our code to execute. This means that it doesn't matter what you put on the thread number 2, it won't block the thread number 1, the main thread. There are different kinds of workers, but today we're going to focus on web workers. That's the API you're most likely going to use during your runtime to send a heavy method or a long executing function to this worker thread or secondary thread. That's parallel asynchronous code. Besides sheer performance, a worker is also isolated from the DOM for security reasons, which makes it a great use case for external scripts. Big shout out to Partytown for doing this in a most elegant and easy way for us. And since we're talking about performance and DOM, we need to talk about SolidJS, of course. By itself, Solid is already extremely performant. It uses Signas to achieve some fine-grained reactivity, which means that every time we change a value, only that will get changed. We don't re-render everything, which means it carries a minimal and extremely granular re-rendering strategy. SolidJS is definitely not the first one, nor the only one to use signals to achieve this maximum rendering performance. But it has become the main example, mostly because of how bought in it is to this architecture in the system. So SolidJS is the view library. But today, we're going to be working on a SolidStart app. SolidStart is the server-side rendering framework of SolidJS. It's basically the Next.js remix of React, or what Nuxt is to Vue. It's what SolidStart is to SolidJS. And the app I chose to bring today is a poor man's Markdown rendering. So re-rendering Markdown at every single keystroke. Just that isn't enough to actually drop the frame rate in a SolidJS app. But it's already a good example of a process that you would like to actually push it outside of your main thread. Because SolidJS is powered by Vite, using web workers require minimum to no setup at all. And the chances are, the setup we're going to see today is actually going to work in most of the other Vite-powered frameworks. So without further ado, let's just jump right into the code. So here we are, the code. This is the composer view of my app. This is the little app. As you see, at this point, it is not doing much. There's no rendering involved, but our server is running. Everything is doing great. We do have some signals already set up. So now I'm storing the note in a signal and I have a few derived states. If you're coming from React, we don't need a use effect for derived states like this. We can store them in a function and everything is going to work. As you can see here in the word counter, 1 word with 3 characters, and then 2 words, 9 characters, and so on. So everything is working so far. This is mainly a text area that I'm tracking up on every key up. And here in this paragraph is where it's supposed to go, whatever I'm going to render out of it. In order for this render to work, what I'm going to do first is set up an effect. So what our create effect is going to do is we're going to create this HTML, which is going to be the marked parse value of our node. And then once this happens, we're going to inject it straight up into the DOM. So I'm going to take my preview container and I'm going to set its either HTML to HTMLs. So hello from Markdown being parsed. And everything is working out, but so far this code is into the same thread. So what we want is to put that into a web worker. So let's go do that. So what we need to do is to create, in my lib folder, I'm going to create an md worker ts. What this file is going to do is I'm going to add this listener on message, which is part of the web worker API. So it's going to receive a message. I'm going to call it raw markdown. The type is going to be of message event and it's a generic, so I'm going to mark it as a string. Once that is done, I can then just do the same logic as I did before. And once that is done, we have a method inside a web worker API that we are going to send this HTML as a message. So this needs to be serialized, but because we're just sending an HTML string, that's going to be good enough. And that's it. We wrote a web worker. Now, back into our composer, we can then import the MD worker from my library. And I'm going to call the MD worker. And then this is a Vite specific thing. We're going to pass the question mark worker. So this means that Vite is going to put our web worker in a separate chunk. So this is for code splitting. So this is not going to be part of our main bundle, which is exactly where we want our web worker to be. There is an option if you want to make it inline, but by default, in most cases, you're going to want it to be in a separate file. So now what we're going to do is create our worker here. And then if our window has worker, because they are not available in the server side, if the worker is already stored in the reference, we do nothing. If it's not, we instantiate a new worker. And now this can go away, this thing go inside, and then we are going to post a message from our main thread to our worker thread. This we're going to send a note, and then as we already have it here, once we're receiving a message from our worker, we are going to have this callback, and this callback is going to set the data of our event to our HTML. And now we're ready to bring back our app. So everything seems to be parsing. So just like that, we have a worker outside of the main thread. And that's it. I hope you have enjoyed. Don't forget to like, subscribe, turn on the bells, everything else, so I can catch you on the next one. Bye.